Hello students, welcome to Neet CET Mentors channel. Today's discussion is based on the capacitance chapter. We have collected previous year questions and we will be solving them by recent years. Be ready with pen and paper. Do solve simultaneously. I will be giving a hint and also solution by explaining the concepts. Understand them carefully, and the same type of or same model questions will come in the 2025. And let's start the question. Okay, yes, the first question: in the following circuit, equivalent capacitance between terminal A and B is. They have given one diagram here, capacitance which have 5 capacitors, and A and B terminals are given, asking for the equivalent capacitance. See, let's say this diagram we can redraw as a imagine these are capacitors, these 4 are capacitors, and middle one also 5. So we can redraw this diagram as like this, and again each capacitors width of 2 microfarad. Okay, what then? See, can't you guess this as a balanced Wheatstone bridge? Because let's say it is a let's label this A, B, C, D. You know what is balanced Wheatstone bridge? It is the ratio A by B is equal to C by D. If this ratio is going correct, then we can cancel that, which is the capacitor which is at the center. See, A by B, that is 2 by 2, which is equal to again C by D 2 by 2, which is the ratio becomes 1:1. So we can say that we can cancel the center one according to the balanced Wheatstone bridge. Then after by cancelling that, we will be getting that diagram as a like this. These are A and B terminals. See, these two A to B are in these two are in series, and these two are in series. The series capacitance formula is C1 C2 by C1 plus C2, that come from the 1 by C1 plus 1 by C2. So those two capacitors having the value 2. So C1 C2 by C1 plus C2 means 2 into 2 by 2 plus 2, which will be 4 by 4. So upper one will be 1. Again below one same case, which will you will getting a 1. Then those two, that is, if you think that is A, then you will have this capacitance, and again have this capacitance with B terminal. Okay, this have a capacitance 1 and this have a capacitance of 1. So how do you calculate for the parallel capacitors? For the parallel capacitor formula, Cp is equal to directly, that is C1 plus C2. C1 plus C2, right? C1 plus C2. If it is so, you can directly add that, that is 2. Right? Answer is 2 microfarad. So the option is 1. From this question, you will come to know what is the formula for the parallel capacitor, what is the formula for the series capacitor, and also Wheatstone bridge. Wheatstone, I will recap it. What is a balanced Wheatstone bridge? That means a ratio, that is A by B is equal to C by D. They are not telling that A is equal to B and or C is equal to D. They are telling the ratio will be equal. Then it is a balanced Wheatstone bridge. If at all that is applicable, then you can cancel the center one, that is a 2 microfarad, which you can cancel it. Then you will be having a two series in a series, two capacitors in a series. Just add them as a 1 by C1 plus 1 by C2, which can be written as C1 C2 by C1 plus C2. After getting for the series, go for the parallel, which is in capacitors parallel will be directly added, so C1 plus C2, so we will be getting two answer. If at all this is the same with the current electricity for the resistance, there series and parallel for the capacitor and resistance will be inverse. For the capacitors, series is added as a uh, C1 C2 by C1 plus C2, right? That is for the series C1 C2 by C1 plus C2. C1 plus C2. If it is for the resistance, just I am giving you hint. Then for the series, which is directly added. Yes. There is a chance of asking question from the resistance or from the capacitor. At least series are parallel from this topic. You can expect one question from this two concepts. Okay. Don't be in the confusion of these series and parallel with resistance and capacitors. Yes, I think you all got it. We will move on to the next question. That is, the equivalent capacitance of the system shown in the following circuit is. Equivalent capacitance are asking. See, I have told you. Can you think that A and B terminals are connected such that these two capacitors, are they in series or parallel? These are in a parallel. Just firstly find this parallel for the first find this CP. After that, this CP and those 3 microfarad which will be in a series, you will be getting the final answer. See how to find CP. CP is equal to, directly you can add a CP, that is 3 plus 3, which will be 6, right? 3 plus 3, which is equal to 6. Like that, if you have a, and again that 3 microfarad one, right? 3 microfarad and 6 are in a series. So how to calculate that? Capacitors at a series can be written as C1 C2 by C1 plus C2. So 3 into 6 by 3 plus 6, which will be 18 by 9, which will be 2, right? Answer is 2 microfarad. Options are not visible here. The answer is 2 microfarad. Okay. Yes. This is how those two questions are based on the same topics, right? Next, moving on to the next question. A parallel plate capacitor having a cross section area of A and separation D has an air in between the plates. Now an insulating slab of the same area but thickness is D by 2 is inserted between the plate as shown in the figure, having a dielectric constant K is equal to 4. The ratio of a new capacitance to original capacitance will be. See, a thickness of a slab which is of a dimension D by 2 is inserting in between the capacitors, and the distance between these two capacitors is small d, and the dielectric constant of this slab is 4, right? Then you know, if at all anything, if at all any slab is inserted between those capacitors, means there is one direct formula. I will tell you. See how to solve this question. If at all a slab is inserted between any capacitors, then the formula can be written as, normally the capacitance is equal to C is equal to A epsilon by D. This is for the, if at all capacitor is in the medium between them is air. If capacitors are introduced, if any medium is introduced between capacitor, means then the formula will be C is equal to A epsilon by D minus T plus T by K. Here in this, what is the A means area of the capacitors, and epsilon naught means permittivity of the free space. D is the distance between the two parallel capacitors, and T is the thickness of the slab that is introduced. So substitute those values. Just see, just I will keep this a and epsilon naught like that only. I will going to d, that is the distance between them given as a d only. And what is the thickness of the slab that is introduced? That is, they have given which has a dimension of a d by 2. So I will be writing d by 2. After that, again t is equal to d by 2, which and a k value. What is the k value given? That is a 4, right? If it is so, then uh, this will be going here in this place, so which will be 8, right? D by 8 for this entire value, d by 8. Here d minus d by 2, that is 1 minus half, nothing but d by 2, right? We will be getting d by 2 plus d by 2 plus d by 8, right? In the denominator, d by 2 plus d by 8. So which will be 4d, which will be 2 4 so 5d by 8. Above we have a epsilon naught by d, right? A epsilon naught by, which here 5d by 8, that is 8 by 5 we can write, and d we can write. Again, this is a epsilon naught by d, which is nothing but the capacitor which was before, which is in the air, okay? After that it was become 8 by 5. They are asking after introduction of that slab, what is the ratio between before, after and before. So we can make this like this is when thickness of a slab is introduced, this divided by capacitor which is in the air condition. So C naught means A epsilon naught by D. Again we can cancel this A epsilon naught of the before and after. We will be having the ratio, that is 8 by 5. You can say that the answer is option B. I think you got my point. See, remember this formula which has derived somehow, which has a derivation. If you know this formula, thickness, right, in terms of the distance between the capacitors. If you do that, uh, you will go on solving and keep almost in the capacitor C, and C is equal to A epsilon right now. Keep that A epsilon naught as a constant, okay? Don't substitute any values, just keep that as at least at last step you will be having some clues. Is it directly cancelling or like that? If it is going to cancel means it will be easy, so keep that as it only, don't substitute any values. Yes, moving on to the next question, that is 31st question. The capacitor of a capacitance of a parallel plate capacitor with the air as a medium is 6 microfarad. With the introduction of a dielectric medium, the capacitance become 30 microfarad. Before, when it is in the air, it is a 6. After introduction of a medium, the capacitance become 30 microfarad. Permittivity of the medium they are asking. Permittivity of the medium is nothing but epsilon, we can say epsilon r, or it is nothing but k. That is, you know, they are asking the ratio, right? Permittivity of the medium. You know, the capacitor at a air is not, formula is A epsilon by D. Like that only, the capacitor in the medium is given by K times, that is dielectric constant times A epsilon naught by D, right? This is the dielectric constant, or permittivity of the medium, you can call. K is nothing but dielectric medium, or dielectric constant, or permittivity of the medium. So they are asking, that K value. How to find that? If you want value of the K, we can make that Ca by Cm. If you do that, you will get 1 by K. If you do Cm by Ca, then you will get K as a numerator. So you will be getting K in the numerator, means directly you will get answer. That is Cm by Ca is equal to K epsilon naught by epsilon A by D, K A epsilon naught by D divided by A epsilon naught by D. If it is so, A epsilon naught by D and A epsilon naught by D going to cancel. So left with the K, value of the K only. See here, if it is so, then they are asking, permittivity of the medium. We got from that is they have given a value, right? 30 by, for that Cm by C is equal to 30 by 6, that is K is equal to now 5, right? If that is a 5, dielectric constant is a 5, they are asking permittivity of the medium. What is the permittivity of the medium means? See, epsilon m, they are asking epsilon m is equal to K into epsilon naught. This is the formula of the permittivity of the medium. So K times the epsilon naught, we have found the K value, that is 5, into what is epsilon naught. Epsilon naught is equal to 8.85 into 10 power minus 12. They have given this in that at 8.85 into 10 power minus 12. If you substitute this doing calculation, you will get a final answer as a 4.4 into 10 power minus 11. The options are given as a in terms of a 0.44. So do this as a 0.44. You will get it as a 10 power minus 10 coulomb square per Newton per meter square. So the important formula is epsilon m is equal to K epsilon naught. Epsilon m is equal to K epsilon naught. If you know this formula, you have to find a K value, then you will get the answer, right? This is how you have to do this. Moving on to the next question. The electrostatic force between the metal plate of an isolated parallel plate capacitor C having a charge Q and area A is. They are asking electrostatic force here between the two capacitors. How to find this type of questions? You know how to get the force equation here. I will tell some, you have to relate mechanics and also electrostatics here. You know, the basic formula, that is work done in the parallel plate capacitor is given by work done is equal to Q square by 2C, right? And also you know work done we can write in terms of force as a work done is equal to force into distance, that is F into D or S, right? If you substitute that if you write this as a 1, equation 1, this as a 2, then 1 is equal to 2 means Fd is equal to Q square by 2C, right? If that is the case, they are asking for the force, so D will comes in the denominator next, Q square by 2CD we will get, right? In these two, the charge remains same and distance remains same. You have to substitute C value in terms of the general formula, that is Q square by 2 into A epsilon by D. So A epsilon naught remains here and D will go into numerator and another D1 is here. So DD cancels here. If DD cancels here means we will be left with Q square by 2A epsilon naught. If it is so, the electrostatic force here dependent on the area between them. Just see one's options, proportional to the square root of the distance between them. No, it's not depend on the distance. There is no meaning of the DD got cancelled there. There is no meaning to tell it the distance between the capacitors. Then second option, linearly proportional to the distance between them. There is no talking of the distance here. Okay. Next, third option, independent of the distance between the plate, inversely proportional to the distance between plate. Okay. So from this equation we got the distance, the force between the two capacitors is independent of the distance between those two capacitors, right? Remember this, these type of questions are commonly asked in the coming exams. Yes, moving on to the next question. A parallel plate air capacitor has a capacity C. Distance of separation between plate is D and potential difference V is applied between the plates. Okay. Force of attraction between the plate of a parallel plate capacitor is. See again force terms they are telling, and they have given a potential and distance between them and capacity of the capacitors. Okay. See how to find this equation means. In terms of charge and potential, how can you write the force? We can write force in terms of V as F is equal to Q into V, right? F into Q into F is equal to Q into, sorry, F is equal to Q into E. It's in terms of electric field. Again, E in terms of V, how to write? E is equal to, E is equal to V by D, right? We can write that as a, okay, F is equal to Q into E, and electric field you can write in terms of Q into sigma by 2 epsilon naught, right? 2 epsilon naught, 2 epsilon naught. Electric field E is equal to sigma by 2 epsilon naught for the parallel plate capacitor. Remember this. This is an important formula. Okay, substitute that. So this is one surface charge density. Sigma is equal to Q by A. From the sigma is a surface charge density. Then substitute a sigma as a Q by A. Then Q into, again Q by A into 2 epsilon naught. If it is so, they are asking force, right? So substitute there Q square, that is you can write this as Q square by 2A epsilon naught. You can they are given in terms of a capacitors and a potential, so somehow substitute this Q in terms of a capacitor and potential. So we can write that as a Q is equal to CV. So Q as a C square by V square divided by 2A epsilon naught. Then you will be getting, this here, what and all get cancelled. C as we can write as A epsilon by D, that is A epsilon naught by D. We can write that as A epsilon by D, that is A square epsilon square by D square into V square by 2A epsilon naught. Here epsilon naught and square get cancels, and again we will be left with the equation, that is, see, we will be left with the A epsilon naught by 1D, and 1D will remain. Again we can write that as a C and V square divided by 2, this and A get cancelled, right? 2D, right? CV square by 2D. See again in this no C square, just one C kept as a C only, under C substitute the value, that is A epsilon by D, then cancel what and all get cancelled, and we will be left with the equation, that is CV square by 2D. See these type of questions, this the answer we got now can act as a formula for the force of attraction between the plate of the parallel plates. If at all they have given this data, along with that, if they have given a value of a potential, distance, capacitors, then you will get for that values and all, you will directly solve from this formula. In physics, what happens means the formula, what those equations, what we will get now, that will becomes a formula for the next solving questions. Remember the force directly, CV square by 2D. Okay, moving on to next question. two thin dielectric slab of a dielectric constant K1 and K2, where K1 less than the K2 are inserted between the plates of a parallel plate capacitor as shown in the figure. Right. The variation of electric field between the plate with a distance d measured from the plate P correctly shown by. Okay. See, let's see here. They have given a graph. The options are given in terms of the graph, right? If they have given in terms of the graph means how to find the difference, that is what electric field versus the distance they are asking. How to find this? See here. Here it is important to consider the distance from this positive charge, this area, and this where dielectric is there, that area, and space, that is that area, and again dielectric area and space area. If you concentrate on that and trying to draw the graph, that is E versus distance, that is D, E versus D graph, where there is no dielectric medium, that space remains constant. That constant is such that the electric field in the air space will be higher than the electric field at the dielectric medium. The electric field lines will be more in the air space than the electric and then the medium. So if you imaginally draw this for the air medium, then next we have a dielectric here. For the second one we have a dielectric. For that the electric field lines are less in the mediums. So just imagine this is lesser than that constant element. After again we have a air here, third medium. So we can draw that above as a constant like this. And above again fourth we got a dielectric. So electric field lines are less, so we can draw that below. After that in the air we got, so that will be again constant like this. So the graph comes in this way, which will hold good for this, which will predict correct for this, right? The option for C holds correct for this graph. Again the distance between those K1 and K2 is more. So the third one what we have represented here now, which has a greater difference. That's it. I think you got that point. The electric field inside the dielectric medium is lesser than the electric field lines in the air medium. If you know that concept, you can draw the graph. Yes. Moving on to the next question. It is parallel plate air capacitor is charged to a potential difference of a V-volt. After disconnecting the charging battery, the distance between the plates of a capacitor is increased using an insulating handle. Okay. As a result, potential difference between the plate is, initially they have a parallel plate capacitor and potential difference across them is a V-volt. What they will do, they will disconnect it and they will increase the distance between those two parallel plate capacitor using an insulating handle. How the potential difference varies here, they are asking. What is the potential difference variation for the second case with respect to first case, they are asking. See, when you charge any parallel plate capacitors, when you charge this by any parallel plate capacitor, it will have some charge in those, right? If it is so, after disconnecting, if the disconnect means the charge that are when voltage are connected, the charge that remains there only, right? After disconnecting also, the quantity, that is the charge of the capacitor, remains same only. So the main important point to be noted here is charge remains a constant here. The Q remains a constant if you disconnect or do
any separation, the charge remains a constant here. If the charge remains a constant means, again they are increasing the distance between them, right? Okay. The second equation, no, the d dash, the in the second case is distance is greater than the d1. Again they are asking for the potential difference value. Potential, how you will, how you can write the potential, v is equal to q by c, or q is equal to c into v. This is the what they are asking. We have told the charge remains a constant if it is disconnected, also if the separation increases also. If charge is constant means the v value dependent on the capacitance. Again, capacitance, how to find the relation for the capacitance? You all know capacitance is equal to a epsilon naught by d. here Here, the area of the parallel plate capacitors. This A denotes the area of the capacitors. They are not changing the area of the parallel area of the capacitors. They are increasing the distance. Again, epsilon naught is a constant value. They are increasing the distance. So, how the C and D are related? Here, C and D are inversely proportional. If C and D are inversely proportional means the distance between them increases means if distance D increases means C gonna decreases, right? If C decreases means again C and V and C are inversely proportional. If C increases means V will going to decrease. If here in this case C is increasing, C is decreasing, right? If C is decreasing means V will going to increase. This is how those relations are important. You have learned three formulas from this, three relations from this. What and all? V is equal to Q by C. From that, Q is constant and C is depending on the V. C is inversely proportional to V. So A is equal to epsilon by D, where D is again inversely proportional. From that, you got the distance relation, and you finally got the answer that if the distance is increasing, capacitance going to decrease. If capacitance going to decreasing, then voltage difference going to increase. Potential difference increases. Option D is the correct answer. Moving on to next question. Parallel plate condenser with the oil that has a dielectric constant 2 between the plates have a capacitance C. If oil is removed, capacitance of the capacitor becomes, always capacitance of the capacitor is directly proportional to the dielectric constant, that is K. They are telling initially the capacitors has the oil which has a dielectric constant 2. After that it is removed. So what happens? Initially capacitance is more, and after that capacitance becomes less. If you know this basic, then just we can have, that is C is equal to, example, you can take a ratio here, right? If you take a ratio, that is C after C before, that is a medium with a C air, then it will be A epsilon naught by D for dielectric constant oil K into A epsilon naught by D. Just keep that as it's only divided by A epsilon naught by D. If it is right means A epsilon by D going to cancel. What is a K? That is 2. Cm by Ca is equal to 2. If it is so, they are asking for the Ca value. Ca will become Cm by 2, right? Ca is equal to Cm by 2. Cm by 2 means, check the options. For that dielectric mediums, no, they have given a C. If it is so, the final capacitance becomes C by 2. So option D is the correct answer. Yes. Moving on to the next question. A capacitance of the capacitor of the capacitance C is equal to 900 picofarad is charged fully by a 100 volt. Battery B is shown in the figure A. Figure they have given. Then it is disconnected from the battery and connected to another uncharged capacitor of a capacitance C is equal to 900 picofarad as shown in the figure. The electrostatic energy stored by the system is. initially they have connected a battery to the figure A. After that they will disconnect the battery there and connect it to the um, figure B, which has a two capacitance. They are asking the electrostatic energy stored in this second one is, this energy concepts, the basics, that is a formula for the energy concept will be U is equal to half CV square, right? That is for the energy. Okay. U is equal to half CV square. I will write here. Then you will get a clue. Half CV square. See what for the finding of the U, the half is a constant. Again, capacitors value are given. For to find a U, you have to know potential. So you know get the potential from the first capacitor. How much was this? They have given in the first case that is 100. Get the V for the second case. So they have not given the voltage for the second case. To find the voltage, you know when that battery is connected to the second one, there we have two capacitance. Again those are also equal to 900 picofarad. To find the voltage of the two common capacitors, if at all the capacitors are identical, then we have a direct formula to find the potential. That is potential common is equal to C1 V1. That is before one figure A, no, that is C1 V1 plus C2 V2. That is for the second case, C2 V2 divided by C1 plus C2, right? Go on substituting the values. That is, in the first case we have a capacitance, that is a C, into we have a potential, that is 100, they are given in data, and we have in the capacitance C2 as again C, but voltage that they have given, the voltage there in the second case is a, you know there is a, which will get into the zero. Why the voltage zero here means, see in the figure you can expect that when they are converting that into like that, the key there is a connection, no, as they have same capacitance, V becomes zero here. The voltage becomes zero in the second capacitor divided by C1 plus C2, that is which will be 2C, right? Then we will be getting 100 by 2, which will be 50. We got voltage as a 50, right? You substitute that to the half CV square to the above equation, then you will be getting, that is this they are asked for the second case. So there we have two capacitance, right? That is half into 2 into half into the capacitance value they have given, that is 9 into 10 power minus 10 into voltage they have, we found out, that is 50 square. Just do calculation. After that we will be getting the final answer as a 2.25 into 10 power minus 6 joule, right? I am again and again telling, that is in the final, in the question what they have told to find, just do the any formula of that, just write it, then you will get what to find for that formula. From that go on adding, you will be getting what to find, how to find, or how the relations are connected. That's that all. Okay, moving on to next question. The equivalent capacitance of the combination shown in the figure is, this is a concept based question. Equivalent capacitance they are asking. Let us label these nodes as a, let's say it is A, and it is a B, this one is a C, this one is a D, right? In this point A, the voltage value uh, and at the point B voltage value are same, let's say, and in the case B If a Vb is here in this node, then again, as there is no capacitors connected, we can have a same value here also. That is, V B is equal to V C is equal to Vd. If it is so, here Vc equal to Vd. If Vc is equal to Vd means we can say that if at all there is the same potential, there is no flow of a current through that. The current only flows from higher potential to lower potential. That means potential difference must be there to flow of a current. If it is so, if there is now in this case there is no potential difference. Potential difference means no supply of a current. So we can cancel this capacitor and we will be left with the 2. That is, if we consider this as A, we are left with the 2 capacitors A to B. Then how to do this calculation? These two are in a parallel. CP, the capacitance parallel is easily given, that is directly C1 plus C2, which for that they have given CP, C values as a in terms of C only, so which will be 2C. The final answer is 2C. So the option is B is the correct answer. Moving on to next question. A parallel plate capacitor has a uniform electric field E in the space between the plates. If the distance between the plate is d and the area of each plate is a, the energy stored in the capacitor is. Okay, they are asking energy stored in the capacitors. Again the basics. Just go from the last only. What is the energy formula? U is equal to half C square, right? Are they talking about the capacitors? No, they are talking about electric field, area and distance. So how to get how V and E are related here? How voltage and electric field are related? Because they are not given in terms of V. So get the V in terms of E. So we know V and E are related by V is equal to E into D. So we can substitute, that is V is equal to E into D. So we can write that as a half into, what is the C value? Because C in terms of A and D are given, so A epsilon naught by D. So what is the V? That is E square D square, right? E square D square. So just do calculation, that is square and D cancels here, and we will be left with the half. We will be left with half A epsilon naught E square and D, right? Check once for this answer. Half A epsilon naught E square D. So option C is here. Option C is a correct answer. Next, moving on to the next question. Two identical capacitors, that are C1 and C2 of equal capacitance, are connected as shown in the circuit. Okay. Terminals A and B of a key K are connected to charge C1 using a battery of EMF volt. Now disconnecting A and B, the terminals B and C are connected. Due to this, what will be the percentage loss of energy? They are asking what is the percentage loss of the energy here. How to find this percentage loss of energy? For that, we have to find the energy at the circuit A and energy at the circuit of the AB and circuit of the CB, right? After that, you have to subtract from the CB to AB, then you will get the difference. That difference is the loss. How in terms of percentage, how it is, how much is this, is the how to tackle a question. So they are asking the loss of energy. You can write that as a change in energy is equal to, we have a formula that is C1 C2 by 2 times C1 plus C2 into V1 minus V2 whole square. This is the change in the energy when two capacitors are given, if you have that formula, these here C1 and C2 are equal, so C1 is equal to C2 here, they both are equal, right? Just substitute that, as they are given equal means the calculation goes so easy, that is C1 C2 you can write it as a 2C by again 2 into again C1 plus C2 2C, so 4, 2C by 4C into V1 minus V2 whole square. you know the potential at now at first case we have V, when it is connected to the CB the potential becomes 0. This is same we have discussed in the previous question. When we connect same to the same capacitors, if the capacitors having the same value means the potential going to be 0 for those, so we can substitute it as a 0. We will be calculating further, we will be getting 2 to get cancelled here, so we left with that is the CV C into V whole square divided by 4, right? If it is so, they are asking percentage of a loss, percentage loss they are asking, percentage loss they are asking means, sorry, here 2, it is not a 2C, it is of a C square, C into C square by 4C, so square and C will get cancelled, C square by 4V, right? Yes, they are asking a percentage, so how to find the percentage? Percentage loss is given by delta u by u into 100, delta u by u into 100. What is the change in the u? That is half cv square, 1 by 4 cv square divided by half cv square. So you will be getting finally, that is here see cv square get cancels, and this half will go into numerator, 4 will get into denominator, which will be half, that is 50%, right? The answer will be 50%. So this was the session we got, right? This is all about the capacitors. This type of questions will common in the NEET exams. They will ask about series and parallel. They will ask about the how electric field relation with those capacitance, and they will ask about the electric field relation. They will ask about the energy relations and the slab introduction also. This is what all the capacitance. Do solve the capacitance questions. I will be sending these to the PDF to you, and be prepared with the current electricity basics. Okay, yes, done.